All right, one quick positive announcement. The highest grade on the last test actually came out of this class. So, drum roll. All right, because I'm a freak and I really like pencils, I get highest chemistry score pencils, and that pencil gets awarded to the next.
What do you get?
You can either choose to sharpen it or save it in your collection forever. Once everyone makes up that test, I still have one person that has been sick this week. They need to take it. Once that's taken, then I can get those back to you. I am going to post those scores sometime after school today. I think most of you already saw what you got right after the test, but I'll post those, and then hopefully Monday or Tuesday I can pass them out, give you a week to make corrections. Definitely want to do that for the midterm. That way you don't get those same questions wrong. Overall, the class average, all the class averages were a little bit lower. I know it's just a hard time of the year with weird schedules and keystone testing. You got a lot of stuff on your plate, but it is going to be important to go back and relearn some of that stuff so that it doesn't smack you in the face on the midterm. Okay? All right, let's take a look at, I have the lab pictures up here. That way when people are calling out lab station numbers, you can kind of match a picture to the actual station in the lab. So question number 1 says, which of the lab stations are useful in demonstrating that air is matter? So before we actually get to that part of the question, I just want to review and make sure we know what matter is. So what is matter and does it matter? Lacey, what is matter?
Matter is anything that has a mass and takes up space.
Okay, anything that has a mass and takes up space. What's another word for takes up space? Volume, you bet. Oh no. Alright, so let's go over the easiest part of this question. It's a two-part answer. Because if you're trying to say that something is matter, you have to either be talking about mass, or you have to be talking about volume. So which ones of these stations up here show that air actually has a mass to it? If you know how to measure mass, it should be a pretty obvious answer. Number 7, Becca. Quick show of hands from the lab groups. When you pumped that bottle full of air, it actually weighed more. Weighed more? Weighed more? Weighed more. Good. Unless something was wrong with the balance, it should weigh more. Now that's counterintuitive for a lot of people. Because a lot of people, when they think of a gas, they think of balloons. And what is often found in birthday balloons? Helium. Hopefully not hydrogen. Hopefully we learned a lesson from the Hindenburg. Hydrogen is less dense than air, so it floats, and so does helium. So a lot of times people think that gases would make things weigh less, but that's not true. When you see balloons floating, it doesn't mean that they weigh less. What actually determines whether something floats? Buoyancy, maybe a better word, density. So when we say something is floating, it doesn't mean it doesn't have mass. It doesn't mean it has less mass. It's saying the relationship between mass and volume is less than what it's floating in. A helium balloon actually weighs more than an empty balloon. Now it's just buoyant, or it's less dense, so it would float in regular air. So you'd have to find a creative way to mass a helium balloon. But yes, this bottle definitely did weigh more because there's particles in it. And if you have more stuff or particles in the bottle, therefore it's going to weigh more. Let's talk about the other one, volume. Which stations up here showed that air takes up space? Number 9, Jordan.
Experiment. I don't remember now, but the one where you blow into the balloon into the bottle.
Okay, so this would be volume. Sure enough, you can't blow up a balloon in a bottle if there's already air in the bottle, because two things can't take up the same space at the same time. You sometimes see this happening in the hallway. turf wars. You have somebody getting up in somebody else's face, and you've got two options. You can either fight for that space, because you can't occupy the same space at the same time, or people just back up and leave and go tell a teacher. The latter option would be better. So yes, in most cases, unless you're me, the balloon ends up not being able to be blown up, unless you have lungs of steel. Any other volume stations up here? Things showing that air takes up space. You might have actually measured that space. Station 8, yeah, you bet. It had a certain amount of space that the air took up, and you were able, by pushing on the syringe, you could change the amount of space that the air takes up. That is not able to be done with solids and liquids. It doesn't matter how hard you squeeze a water balloon, you're not going to make the water in that water balloon get smaller. Whereas if you squeeze a gas, you can easily get a gas to go smaller. Those are some of the properties that you saw on your Unit 2 test. Any other stations up here showing air takes up space? What happened with the water with the cup upside down in it? Did the water go up into the cup? No, why not? Yeah, there's actually something in the cup, and that something is called air, and because there's something in the cup, the water can't fill up the cup at the same time. So this one shows that air takes up space, or air has volume. You can see this if you wash the dishes. Any other volume stations? I think the only other one was number 9. This is a little bit hard to see. What happened to the amount of space that air takes up when you put it in the boiling water? What? It gets larger, yeah, it gets bigger. So this is actually a special property for the volume of gases. You can change the volume of a gas based on temperature. You might want to star that in your data table. That's called Charles' Law. Charles' Law says if you change the temperature of the gas, its volume will predictably change, and you can actually measure that and solve that using an equation. We'll do that later in the unit. So I think we pretty much hit all of the matter stations, both mass and volume. Let's take a look at question 2. Which experiments are useful in showing that air is pressure? Nick. And keep in mind, pressure is a force, something pushing or pulling over a given area. So where did you see gases pushing on things in this lab? Yep, number 6. What caused the can to crush? There was air pushing on it, or there was air pulling on it. Either way, it got crushed. So pressure. Any other pressure stations?
Maybe experiment 3 again?
Experiment 3. Yeah, this could be a volume or a pressure station. Because there's air in that soda bottle, it was pushing back on the balloon, and that pressure beat out your pressure. Yeah, so you could label this one pressure. Any other things getting pushed on? Keeping things in place or keeping things where they belong?
5 doesn't that air push the water on?
Yeah, I mean, you're not able to see the air, but for some reason that water didn't flow out of the opening. Could it be because the air is pushing on that water? Sure, and if air is pushing, creating a force, that could cause pressure. So we don't think about that air on a regular basis. But it's there. Any other magical things happen, maybe because air molecules were pushing or pulling on things? What happened in Station 4? You put a piece of plastic on a test tube that was filled with water. What happened when you turned it upside down? Did the plastic fall off? No, it stayed there. What could be causing that plastic to stay there? Austin? You're just
Air pressure.
air pressure. Could there be air pushing that piece of plastic in place? You bet. So pretty much anything that we didn't label as mass or volume could be considered pressure. What kept that water from flowing out of the test tube when you turned it upside down in number 7? Pressure. You might actually want to star number 7 in your data table. This is a basic principle called a barometer. We'll talk about that more next week, but a barometer is an instrument that measures air pressure. It's basically a pan filled with a liquid. Usually it's not water. A tube filled with that same liquid, and depending how much air pressure there is, it'll either make that liquid go up the tube more or up the tube less, and that's how we measure air pressure. So that's a barometer. Anybody know what that liquid is usually used in a barometer? Mercury. In the old-fashioned science classrooms, when you walked in the door, there'd often be a mercury barometer sitting on the side of the wall. The issue with that is there's a lot of mercury in that, and if it breaks, you pretty much have to evacuate the whole school. So now we use electronic barometers. What kept you from being able to drink water up the straw? Pressure. It was a lot easier to drink the air coming up the second straw rather than the liquid in the first straw, so that kind of simulated a broken straw. It's pressure that allows you to drink out of a straw every time. And we'll kind of prove that next week when we talk about our kinetic molecular theory. Any questions? So that was number 1 and 2. Number 3, explain any predictions that might not have matched up with the actual outcomes in the experiments. In other words, which station maybe surprised you the most? I heard some screams back there, so I know there were some surprising things. Lacey, what surprised you the most? Which one of the stations? The fact that you couldn't blow up the balloon?
Yeah.
What did you think was going to happen?
I thought it was like.
Just pretty easy to blow up?
Yeah.
Okay. Jenna, which station surprised you the most?
I actually said the same thing.
Same thing? Nick, what about you?
Same one.
Same one? Any other surprising ones? Was the can a surprise, or have you already done that one? You've already done that one before? You've seen it on the internet? Okay. Jordan, what were you going to say?
I was just
The can, yeah. That's a pretty cool one you can actually do in your kitchen if you have little cousins over the holiday break. Just get your parents' permission. Everyone has like a big tub of water that they can put the can in, fill up the sink, take it right from the hot stove. You just got to make sure that you can actually put a hot can on a hot stove. Some of the new stove tops, you can't do that or you're breaking. But that would be a neat one to do for little kids. Let's take a look at question number 4. Some real-life activities that show air is matter. And keep in mind, matter could go 2 ways. Either air has mass or air takes up space. So a real-life example. Number 18, Alex.
I didn't have
Okay. Can you think of an idea where you put air in something and it weighs more? A container filled with air weighs more. Okay, a pool floaty. So basically, you're causing the person to take up more space. Does a floaty weigh a lot? No, but it takes up a lot of space, so it changes the density of the individual with the floaties. Yeah, so a floaty would be a good example. Air takes up a lot of space, but doesn't have a lot of mass. What's another real-life example? Ben. Okay, and is that more of a pressure or more of a volume? Okay, it's kind of both. Yeah, you can actually measure the pressure in the tire, how much air is that pushing on the tire, and when a tire is filled up, it definitely takes up more space. Can you think of something that would weigh more if it has air in it? And based on how much more it weighs, they would know how much to charge you. If you've ever been to Baumberger's, out back they have a little filling station. Propane. You know whether a gas propane tank is filled or not based on how heavy it is. And some of the new propane tanks actually have a little scale on the bottom. Depending how much they're pushing down, how much they weigh, it'll tell you whether it's full or empty. So they put your propane tank on their scale, they figure out how much it weighs, they fill it with propane, it weighs more because propane is a gas and you're putting something in there, and depending on the difference in weight, they know how much to charge you. Whether it's a 20-pound tank, a 40-pound tank, however much propane they put in there. Any other real-life scenarios? All right, let's take a look at number 5. Something showing that air exerts pressure on a real-life basis. Zach.
it had air center at higher elevations.
Okay, air is thinner at higher elevations. I'd say that more goes with, well, that kind of goes with pressure because if you go on an airplane, there's less pressure up there. That's why they have to pressurize the air cabin. Number 7, Becca, a real-life example showing pressure.
I said like when you like fill up, like when you blow up the juice pouch and then you step on it and the straw like splits.
Oh yeah. So you can kind of create like a little juice box bomb. You sometimes see that in the cafeteria. Not that any of you would do that or anything. What? Did it the other day. Sometimes you see people taking an empty water bottle and they like twist the bottom of it, squeezing that gas into a much tighter place. You have more molecules bouncing into things, creating pressure, and then the cap shoots off. All right, before I collect this, take a look at your rerun conclusion. Look at the thing that you wrote down that you were uncertain about. And if there's any leftover questions, this would be a good time to ask them. Also, if something that you were uncertain was already answered, indicate that. That way I'm not writing a bunch of answers that you already know the answers to. Anything you're uncertain about? If not, you can go ahead and pass those up the aisle. Unless you're using a Grace Pass turning it in Monday, just make sure your name's on it.